That was some funny shit when that happened. Alright, there's two different ways to set the PID controller up in Visuino. The one on the right is stock. The one on the left has all of the sync pins enabled. This is so we can set EEPROM values and save them. So we have to add your 5 analog values and then 1 digital component for this project here to do it the right way. Alright, you do this by changing the properties in the PID controller's properties panel. Alright, down in the lower left corner is where you click on the little thumbtacks, and you can change each of the values from none to sync pin by clicking on it. Now, also in the properties there, you have to change them all to 0 or false. That's because if you leave something there, it's going to add or subtract or do whatever. It's going to change them numbers. I'm not sure if it will or not, but that's one of those things I'm not going to take a chance on. So your components are your accelerometer and your Kalman filter, your RC block, your timer at 160 ticks, your PID controller with your analog and digital components set up. Don't forget to set your AREF pin if you're using a digital. If you're not using a digital, if you're using an analog cell, set your AREF pin to what voltage you're using. Alright, we're not going to use our integral or derivative values at this point right now. We're mainly going to look at these two funky symbols. They just mean the sum of. Okay, that's all those mean. And then we're just going to deal with the proportional value at this time. Alright, so this is basically what you want to see on your graph. It crosses over the other way and it'll gradually increase. You can see it just kind of gradually increases in distance a little bit. And you bring it back and it'll kind of stick there in the center. And then if you bring it all the way down, you know, you can see that's up at 1. That's the maximum it's got is a 1. You bring it back down, and if it's up there, you'll see it takes a little while. Once you start moving it back, it takes a little while to start dropping down. And then when you bring it all the way down, they'll start gradually decreasing until that red line goes all the way down to 0. You see it getting bigger right now, bigger and bigger and bigger and bigger. Alright, and then when I take it back up, it's there. What we have to do is keep that from having that delay in that increase. That increase has to hit when it hits its point, when the robot says, hey, I gotta go back. That's when that spread needs to stop happening. If you get it where it's gradually spreading apart like it is now with it forward just a little bit, that's no good. It can't wait to get up that far. Now that's the whole idea behind having to tune your PID controller is how far can this robot tip? How far can it afford to tip without me having to hit the wheels to get it straightened back up? Now that has to be an exact, it has to be close. It can't take its time. If you're way over here and it's finally going to take its time to get all the way to 0 to the 1 range and not have to increase, then it's too late already. When you're tipping just maybe 2 or 3 degrees, it should be, if it needs to, it's going to kick them wheels up to 100%. It can't just be lollygagging around. So from the 1 right now, my values for proportional, I have a 1. My integral is set to 0.1. My derivative is set to 0.1. My set point is 0.5. And my starting value is a 0. Those are the values I have in there right now. Now they can only get better from here. So let me do a couple more changes in the numbers and we will look at this graph again. Alright, right now I'm holding him on his balance point. And the graph is looking pretty good. Tip it just a little bit and that number goes up to react pretty well. It's getting there. It's a little bit jerky still. You tip it back and it should gradually keep increasing. But what the thing is, now what I'm seeing is that it'll gradually keep increasing faster. It's not taking so long to react. And it's also centering itself a little bit quicker. It's centered right there, and now those two lines should come together over time. They're getting there. See it kind of moving itself down a little bit. They're just about there. See, what the issue is it's still waiting. It's still taking too long for it to finally reach that point. When you're at your center point and you move it just a little tiny bit, it needs to react. It can't wait. So what I've done is I've increased my proportional by 1. Now it's set to 2, and the integral and derivative are also still set at the 0.1. I'm going to take it up to 3 and see what happens next. His damn wheel broke, so I'm going to take the time to add his suspension, his upgraded suspension onto him right now. And the next part will be what it looks like. And this is what I've come up with. Kind of up and down. I'm going to add the shocks. So what I've done is I've attached the motors a different way to everything. Now I'm going to take these servo little brackets and I'm going to kind of glue them on like that. Alright. And then each of these is going to get a stand up, kind of like a ball joint. But this screw is going to go through. Oh, well, I got to get another screw now. And then each of these is going to have one of these extensions on the end like this glued on and attached. And then these are going to get glued right to the motors with this wonderful stuff called goop. I love this stuff because it sticks really good. It withstands impacts, and if you just tug on it, it comes off everything, including electronic boards. So I love this stuff. It all comes off. You can peel it right off, and it normally withstands everything pretty well. So let me make these, and then I'll let you know how it's going.